a rather gigantical integration skill in your tool kit. Integration by trig subs opens the door for a million integrals you might not have been able to do. Unfortunately, it's an advanced integration technique. It's like a Calc 2 integration technique. Calc 1 they just couldn't do it. There's too much you'll see they haven't seen before, but the idea is this. Integrals that before today you would have thought, oh, that's not integrable, actually are integrable. This, for example, if this is a definite integral, I'd probably think, okay, it's a circle, area by geometry, blah, 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 blah. But as far as antiderivative, couldn't happen, you would think. But you're wrong. Okay? This guy, you think, oh, that can't be integrated, but you're wrong. You can't. That guy, integrable. So, are you ready to expand your integrable world a little bit? Wow, that was not the response I was looking for. I felt like I really sold it, but apparently no, you're not buying. It's okay. I'm going to drop it at your doorstep anyway. Here it goes. Like U sub is usually taught, typically the teacher teaches you, first of all, make you this, and then you kind of get used to how U sub works, and then eventually you need to figure out what to make you. Do you agree? Trig sub's the same way. I'll tell you today, I'll tell you, hey, use this trig substitution, but look for patterns in why, as I tell you, this is the substitution, and tomorrow, when it's your choice, you will have a kind of a leg up, because tomorrow you're going to have to choose yourself. So here we go. This is what it looks like. You're going to get an integral that's algebraic, and you're actually going to bring trig into it. That's why it's called trig substitution. Now, why you would do that, it seems like we're complicating things. You'll see. But I can basically sum it up with one word: identity. Identities are why you trig sub. If you let x equal sine theta, then this integral becomes 1 minus sine squared theta, which is cosine squared theta, which is just cosine theta. And that's pretty great. Now, just like in U sub, you have to account for the dx as well. So things will get a little dicey there. So what is dx, please? dx is cosine theta d theta. So I actually do have a cosine theta d theta out here, and it's not quite as simple as I was making it sound. It's a little more complicated. This is actually why it's an advanced integration technique. You have learned how to do lots of trig integrals. All those trig integrals you've done, they were preparation for today. They're not just, hey, it's fun to integrate trig. It's preparation for trig sub. So, how do you integrate cosine squared? Power reduction identity. Well done. Yay. I didn't even write it over there. Wow, you just remembered that. Great for you. Who did that? Who? Give yourself a little. That's the spirit. Okay. I could have sworn it came from over here, but apparently not. Sorry, you for your voice. So, power reduction identities: 1/2 plus 1/2 cosine of 2 theta. If you don't know those by now, first of all, what's wrong with you? But second of all, you better learn them because they're not going away. Do you want to take the half out or just integrate the way it is? Just integrate. Okay. So what's the antiderivative of half? 1/2 x theta plus. Now, technically, by the book, that's a U sub problem because the 2 thetas within. But gosh, if we can avoid that and just kind of mental U sub this, that would be great. So what's the antiderivative? 4. Right? Now, that's important that you can do that because you'll save yourself a lot of time, and you're going to need to be able to save yourself a lot of time. Are we all cool with that 4 this time? All right, cool. Plus C, am I done? You're not done. Just like U sub, you have to sub back. So, sine theta, x equals sine theta. What's theta equal to? Inverse sine of x. Cool. 1/4 of, now, this is a bit of a problem because our fact is about theta, not 2 theta. So what do we do with that problem? How do we solve that problem? Oh, it's sine. Yes, sorry. Thank you. Good call. 2 theta, though, is the problem still. So what do I do? Okay, if the problem is that it's 2 theta, not theta, then I guess we should make it theta. How do I get it to something theta-ish?
Sine 2 theta.
Yeah, sine 2 theta is equal to 2 sine theta cosine theta. Identity, yeah? All right, now we're getting there. We're almost done. We know that the sine theta is just straight up x, yeah? To solve for the cosine theta, or to sub for this, you need to draw a triangle. If x equals sine theta, that implies that opposite is x, hypotenuse is 1, and adjacent by Pythagorean theorem is 1 minus x squared, okay? Therefore, the cosine theta is what? Root 1 minus x squared over 1. Okay, you have to draw that triangle to sub back for some truth. All right, so far so good? Questions? Let's try another one. Say I did that second one I introduced you to up there. Now this one's tangent. Why do you reckon we're not using sine? Why not 4 sine theta here again? That's what we used last time. Focus on the root. Yeah, the root will be, so if I use sine, 4 sine, I'd have 16 sine squared plus 16. Does that do anything? Sine squared plus 6 plus 1 is nothing. It's not an identity, yeah? So the reason you're using tangent is because of the order of this square. Now these guys are kind of cursory. They're kind of side stuff. The square is the start of the show. That's what you choose based on, and you choose based on what gets you the identity you need, all right? So with that substitution, the x is 4 tangent of theta. The radicand is 16 tangent squared theta plus 16, and dx, what is it? 4 secant squared theta d theta. Okay, cool. All right, a lot of cleanup to do here, first of all. What's the net constant? What's the overall constant after all the 3 things going on in there? 4 in the denominator, right? Okay, I'm going to leave secant. I'm going to leave tangent. What about the root? After you pull the 16, if we could do this all at once, that'd be great. But if you pull the 16, you get tangent squared plus 1, right? And tangent squared plus 1 is equal to? Secant squared. And square rooted is secant. Now, if that's too much at once, then I encourage you to break it up into chunks. But I took the 16 out, tangent squared plus 1. For your note purposes, I wouldn't actually do this on a problem. But this is what went on there. You follow? All right, so here we go, cleaning up a little more. 1/4 of secant tangent in the denominator, secant over tangent, yeah? It's not a known derivative. Doesn't seem like it's ready for use of. At least not that I see. What should we do? Can we break an integral up into of a quotient or a product into 2 integrals? Is that a thing? You can't do that. So what else? Sines. I heard sines. Cosines. I like sines and cosines. Let's go sines and cosines. Wouldn't you say that secant is 1 over cosine, and tangent is sine over cosine in the denominator? So cleaned up, isn't this cosecant? We? All that identity work has a point. 1/4 cosecant. This one was a little iffy there, so I expected some people to be a little iffy on some of these, so you should definitely study for the final. The antiderivative of cosecant is log of cosecant minus cotangent. Yeah. All right, so this is 1/4 log of absolute value of cosecant theta minus cotangent theta. And am I done? No, I need to draw. So, based on this statement, or its equivalent, x over 4 equals tangent theta, draw a triangle. Theta, obviously, is the angle. Put the x and the 4 in the appropriate place, given that tangent is opposite to adjacent. That leaves us with hypotenuse by Pythagorean theorem, x squared plus 16 square rooted. That should be all I need to sub back. What's cosecant of theta? You might be right when you think that. Sine is so cosecant hypotenuse to up. Yes, I agree. X squared plus 16 over x, yeah? And cotangent is TOA, and is a over O, so 4 over x, yeah? Plus c. You can imagine that the answers in the back of the book might be changed. Maybe they put it together. Maybe they put a 4th root. I don't know. I don't require cleanup, okay? If you got there and call it good, you're good. If you have questions about, hey, does my answer match what their answer is, I'll be happy to answer that as we go, if you're not sure if your answer matches. All right, let's go to this guy. Okay, so x equals 3 secant. Actually, the next 4, I think you probably have a clue now. This one's a little easier, but then the 3 practice ones are a little rough. So try this one. Try this one. Oh, that's nice. That's great. Pretty nice. If you did things well, okay, remember, just like you said, trig sub is supposed to get you an integral that's easy. Well, don't get any easier than that, right? So did you get 1/3 of arcsecant of x or x over 3? X over 3 plus c. How do we do? All right. Now that one was easy, and it lulls you into a false sense of security. So these are a little grosser. This is about as gross as I could find, close to college level or used in college textbooks kind of stuff. So let's practice it. Write small. Yes, that is ominous, isn't it?
That root file over the X too, or just over
That root is not over the X. You might be wondering why I wrote it so wacky. That's kind of the way it's going to come tomorrow when you guess for yourself. That's a humding, right?
a little bit.
Good thing you're so smart. answer? What do you think? Okay, now if you're not sure about what I did, feel free to refer to step here is there. This is step. Okay, so if you're not sure what I did in a step, let me know. If you are sure and you've got the same thing, go on to the next one. This is good practice. This takes a while to master. I know you guys are being smart. You're in the habit of mastering something immediately, but higher level math takes a while to get this without error. Oh, actually, can we pause here? Sorry, I want to talk about something. All right, so when you make a substitution with a definite integral, there are two okay ways to deal with this. One is to actually change the limits. The other is to find the antiderivative, never write the limits, no limits, basically an indefinite integral, and then bring it back later. Now, that's actually a pretty useful skill in higher level math. I think you guys know how to change the limits. You've done that before. Can we do it the second way, just so you are familiar with what I'm talking about here, all right? So we're going to evaluate this, we're going to start by just saying, forget the limits. I want to know what is the antiderivative. Now with our substitution, we know that x is sine theta, so dx is cosine theta, d theta. And with substitution, then we get sine squared, cosine theta, d theta in the numerator, and root 1 minus sine squared in the denominator. Yay? With a little bit of cleanup, what happens? This becomes cosine squared square root. It's cosine. It's just sine squared. Yeah. Okay. The power reduction identity for which is 1/2 minus 1/2 cosine of 2 theta d theta. Okay. The antiderivative of which is 1/2 theta minus 1/4 sine of 2 theta. Don't worry about the plus c. That's not really an issue because it's a definite integral problem. Now we need to sub back. What is theta equal to? Inverse sine of x. And how do we deal with the sine of 2 theta? Identity 2 sine theta cosine theta. So we get 1/2 inverse sine of x minus 1/2. What's sine theta equal to? It's just x, yeah? And the picture to get the cosine involves opposite x over hypotenuse 1 with adjacent root 1 minus x squared. So it's cosine root 1 minus x squared. All right. Do you agree that we found the antiderivative there? Right? So if you did this with a non-subbing for the limits work, you would say, therefore, or so, the integral from 0 to 1/2 of x squared dx over, I already forgot what it said, root 1 minus x squared is equal to what? Now, the antiderivative minus 1/2 x root 1 minus x squared to the 0 to a half. You follow me? Now it is important if you use this method, and it is good to know both, that you never, not once, ever write the limits of integration on a problem where you sub 4. Okay, if you ever attach 0 and 1 to any kind of theta statement, you're gone. Your professor will kook out on you. You're going to freak out. Okay, do not ever write the bounds. Just do the use sub, okay? Or the sub, but find the antiderivative. Here we go. We're still not out of the woods. For Pete's sake, here it is. 1/2. Tell me, what's the arc sine of a half? What is it? Pi over 6, yay? Minus 1/2 of 1/2, and what's root 1 minus a half squared? Root 3 over 4. Minus, what's arc sine of 0? 0, and the other one is also 0, I think you'll agree. So we're cool there. So we get something like pi over 12 minus, let's go with 1/8 of root 3. What do you think about them apples? Okay? Are we cool? All right, try the last one. Put you over the top and put you into Mastery Town instead of just Have a Clue Town. Goodness. What is this? What comes out front of 4 or 16? 16, yes. When you get 1 over secant squared, I had 2 people in the last class say, oh, so that's just 1 over tangent. Yes? Can you integrate like that? Yeah, that's enough. That's nice. Oh my. Doo-be-doo, doo-doo-doo-doo. All right. Running out of room. I don't know if you can see that, but there's my answer. You get something like that. 1/24 of 1/2 arctangent of 3x over 2. Yikes. Plus 3x over 4 plus 9x squared. We? That plus C, senor. All right. Well, that is that. Yay. Questions on 111. 111 questions. Exchange. What did you say? 25?
We do 10.
10? Is 25 a question? I just 10.
No. 11.
11. 25? 25?
Yeah, that's what he said.
Okay. 10, 11, 25. Boom. Yeah, louder. 2, 3. Man, I'm so proud of you. That's great. All right. 111, number 10. Find a vector of magnitude 7. I remind you, magnitude is shown by double bars. 7. Normal to. I believe you're allowed to use your calculator to calculate the derivative. Although I guess we could use logarithmic differentiation if we wanted to, but still got another percent 2.3. So we can find that by Newton's method. Ooh, this would be a good final, right? Gosh, I can make you take the derivative by logarithmic differentiation. I could then have you estimate that by Newton's method. Oh, that would be super. If I didn't have to grade it, I would say we're doing it. All right, what's the first thing you do? What do you do? Did you get started?
No.
Okay, so you want to say the curve looks like this, and here's 2.3. Before I can find a normal, I have to start by finding a tangent. So you take your calculator up and take the derivative of that at 2.3. And if I remember from last class, like 1.6 or something. Anybody have that? 1.16.
Wait, no.
Oh.
60.
661?
60.
681. That sounds familiar. Okay, cool. All right. Now, what we just found there is that the tangent vector has a rise over run. Make it a ratio. A rise of 1.681 to a run of 1. So in component form, we could say a tangent vector is, what would come first, the 1 or the 1.681? The 1. The horizontal comes first, then the vertical. Okay? Now that's the tangent vector. Now we have two things we still have to do. We have to find a normal to get it perpendicular, and then we have to make it the right length. It doesn't matter which order you do those two steps in. What do you want to do, the normal part first or the length first? The normal. The normal is, how do I make it this way? Instead of going up 1.6, we go over 1.6, up 1. So we switch and negate both or just one? Just one, it doesn't matter which. You have two possible solutions, either one fine. Though obviously on a multiple choice, you need to find the one that makes sense with yours. Okay? Now that is the perpendicular, but if I line the Pythagorean theorem on that, the length would not be 7. It's something else. So now we need to make the length 7. How do I do that? Right? When it says magnitude 7, that means the length of the vector needs to be 7 units. Yeah, so now let's make it a unit vector. To shorten it up, you divide by the magnitude of the vector, which is just Pythagorean theorem. So keep the components in the numerator the same, because that handles the direction being correct. But then you shorten it by Pythagorean theorem. Oui? Now that vector is perpendicular and 1 unit long. Now how do I stretch it to be 7 units long? Multiply by a factor of 7. Stretching it so it's 7 times negative 1.681 over the magnitude. I'm just going to call it, if you don't mind, I'm just going to call it magnitude of the vector. And 1 over 7 times 1 over the magnitude of the vector. Okay? Divide. And let's square root, not magnitude. Okay? Okie dokie. 11. Is 11 still a question?
Yes.
Okie dokie. 11. Yeah, 11. There's 2 ways to do this. I maybe thought about this the hard way, but I don't know. Okay? There are a couple different approaches to this, so just think your way through it. What's one thing you can do?
I combine this.
You combine them, okay. So if you do that, you get x squared sine of x and sine of x minus x squared. And I assume then you at least mentally thought what happens and it's 0, 0, yeah? So by L'Hopital, actually you justify L'Hopital, sine minus x squared goes to 0. X squared sine goes to 0. So by L'Hopital, it is the limit as x goes to 0 of cosine minus 2x over first stays the same, derivative of the second, plus second stays the same, derivative of the first.
I got there.
All right, out. Then, if we direct sub, what do we get in the top? 1 in the bottom, and that is does not exist. Now, what if does not exist was not a multiple choice answer? What if all they had was infinities and negative infinities? What would you have to do? Yeah, you're going to have to figure it out. Now, this actually is D and E, not because it's a 0 in the denominator, but because it's actually 2 different limits on either side. The x squared is definitely infinite on both sides, but sine is infinite, negative infinite, and so that's why it's D and E. It's because these 2 limits are different. Okay? Okay, 20, no, yes, 25, question 25. 25 is, it's not replaced, right, it's just normal. Okay, so this is a secondary use of U sub. Typically, U sub is an integration technique that handles a function within a function. Anti-chain rule, if you will. So if you had something like this, then obviously you would use sub because it's a chain rule derivative. But another use of U sub is to deal with the unfortunate sum problem here. This you have no hope because you can't integrate those separately. Obviously, anybody with worth their salt in calculus knows you can't do that. You definitely can't distribute because of the root, so that's out. So it's a kind of a non-starter. Well, U sub gets you unstuck. if you let u equal x plus 4, then the rate, what's it called again? A root. A root becomes u. Now, you have to sub for x. What is x in u terms? If u is x plus 4, then x is u minus 4. Now, if you're like my AB students, then you say, I don't see what the point is. You still have a product with a root. Well, what's the point? Yeah, now you can distribute. And so it is u to the 3/2 minus u to the 1/2. And then, okay, so u sub deals with a couple different problems. All right, and then obviously you still have work to do, but you can go. 3, question on 3. Anybody need 3? All right. Ooh, that's a hard dinner. I wish it would have said, it says tangent line, but the little memo says 99, which is differentials. Did you use tangent line or differentials, or you didn't do it and I can just do it whatever I want? Differentials? Excellent. Let's do differentials because that's best practice for the calculus, the test. So xy squared minus 4x squared y plus 14 equals 0 has the point 2, 1 on it, and we're supposed to estimate the curve when x is 2.1. Okay? So think of it like this. When I say the curve, think of it as the y. By changing, if delta x or dx is 0.1, then what does y change by from its starting point 1, yeah? So I need to estimate the change. Estimating delta y is done by dy. dy is the derivative. The x, now this isn't really a function, so notation-wise that's probably kind of neat. But you get the idea. Well, let's find the derivative first. The derivative for dy dx is x times 2y dy dx plus, I'm a little rusty on my implicit here. X, okay, I feel like it, that's right, plus y squared minus 4x dy dx minus 8xy plus 0 equals 0. Did I do that right? I think I'm good there. Okay. So dy dx has factors of 2xy minus 4x, and the other stuff is 8xy minus y squared. If I take these guys over there, so dy dx is 8xy minus y squared over 2xy minus 4x. So as far as dy dx at 2, 1, let's go with 16 minus 1 over 4 minus, no, that was indeterminate, or undefined. 15 over negative 4? Yeah? I'm pretty confident with that, but I wouldn't bet my life on it. Negative 15 fourths is the rate of change. X is changing by 0.1. So that is negative 15 fourths times 1/10. So negative 3/8. Okay? And so the last thing that you don't want to screw up is to answer wrong, right? That's the change, the estimated change in y. So if the old y is 1, then the new y is approximately the old y plus the change we estimated. So I'm feeling 1 minus 3/8. Y would change to 5/8 or 0.625. that's right.
Others 15 was 12.
It was 12?
I think the 4x squared.
You could have freaking told me that 10 years ago.
I was confused.
This is 4x.
Should it be squared? Because
Yeah, I took the derivative on y. Thanks, awesome, that's super, thank you. Okay, so this, well, it matters. Don't make a claim for me, buddy. 4, 16, negative 12, so this is 5/4. So this is 5/4. Actually, thank you for telling me I was rather. All right, so negative 5/4 times 1. Negative 1/8. 1 minus an 8 is 7/8. Boom. Okay. Good thing I didn't bet my life on it, eh? All righty. Have a lovely day. Howdy.
I think negative 1. Don't you changing it from 2 to 2.1 then?
So it's from where you started to where you're going, so you're increasing x.
So when, okay, so when
It's positive, yeah. It's from, it's start to point your s to.
okay.
Okay, start the recording.